Okay, I want you to picture this. You're Hemi-Unu. You are the chief architect for a literal god king, Pharaoh Khufu. We're in Giza, way back around 2560 BCE, and he has just given you a command. Not a suggestion, mind you, a command from a living god. And, well, it's completely, utterly impossible. So what's the job? Just this. Build him a tomb that will last for eternity. Yeah, that's it. Not just some building, but a monument designed to literally outlast time itself. For poor Himiunu, this wasn't some thought experiment. This was a real problem that pushed the absolute limits of what humans could do. The nightmare starts with the materials. We're talking 2.3 million blocks of stone, limestone, granite, and these things are massive. A lot of them weigh more than an elephant. Some of the granite beams inside try 80 tons. And you've got to quarry them, drag them across the desert with no wheels, and then somehow lift them hundreds of feet into the air. And where are they going? To the top of a structure that's going to be 146 meters high. To put that in perspective, that's like a modern 40-story skyscraper. And your toolkit? Ropes, levers, and pure muscle. That's it. Good luck. For Hemiunu, the pressure is just immense. I mean, the stakes could not be higher. One tiny miscalculation in the foundation and the whole thing is ruined. One mistake in the logistics and the project grinds to a halt, and you failed your god. And in his world, failure isn't just getting fired. It's probably a death sentence. And that's where I enter the picture. Hello. You can call me mathematics. And let's get one thing straight. My story doesn't start in some dusty classroom with chalkboards and abstract proofs. No, I was born right there, in the sand and the heat. I was forged out of pure necessity. Himiunu didn't need a philosophy. He needed a tool to solve an impossible problem. He needed me. So, let's get into it. The first big hurdle wasn't even lifting the stones. It was taming the land itself. So how did I help them figure out the geometry for this monster of a building? Just think about this for a second. The foundation is huge, right? We're talking the size of 7 football fields. And it's not on a nice paved lot. It's on rough, uneven desert bedrock. If that base isn't perfectly, and I mean perfectly level, the whole pyramid is going to be unstable. So how on earth do you do that with their basic tools? Well, the solution was just brilliant and so simple. They used a basic law of nature. See, they cut a whole grid of trenches into the bedrock. Then they filled them all with water. Water always finds its own level, right? So they just had to mark that water line, drain the trenches, and then chip away all the rock above the marks. And the result? A base that was level to within 2 centimeters across the whole thing. Incredible. Okay, so a level base is great, but that's only problem number 1. It also had to be a perfect square. Even a tiny little error in the corner angle would get bigger and bigger as they built up, and the 4 sides just wouldn't meet at the top. Total disaster. And again, the answer was this beautiful, practical piece of geometry. All you need is a rope with 12 knots, all spaced out evenly. You take that rope, you form a triangle with sides of 3, 4, and 5 units, and here's the magic. The relationship between those numbers forces a perfect 90-degree right angle to appear. It just has to. So they did this at each corner, and bam, a base so square that the sides are off by less than 0.1%. But now for the big one, the final boss of geometry, you could say. How do you make 4 gigantic flat faces meet up at one single point, almost 150 meters up in the air? Every single block, all 2 million of them, had to be placed at the exact same angle. If they weren't consistent, the whole thing would be a lopsided mess. The faces just wouldn't meet up top. To solve this, the Egyptians came up with a genius idea called the second. Now, forget all the stuff you know about abstract degrees and angles. The second was way simpler. It was a physical ratio, a rule of thumb. You could almost call it the granddaddy of trigonometry. And the best part? Any worker could understand it and copy it perfectly every single time. And for Khufu's pyramid, the rule was super specific. For every 1 royal cubit you go up, which is about, say, 20 inches, you had to move inward 5.5 palms. That's it. That one simple rule defined the entire shape of what was then the biggest building in the world. So imagine this. Every single worker, every foreman, on every single layer of that pyramid had one simple instruction burned into their brain. Go up 7 palms, move in 5.5. Go up 7, move in 5.5. Repeat. Over and over and over. And by just doing that, relentlessly, they guaranteed that those 4 faces would soar up and meet at a single perfect point. But look, taming the stone, that was only half the fight. Hemiunu's problem wasn't just about angles and lines. He had a whole city of people to manage, a whole army of builders. And to do that, well, he needed me again. But this time for something totally different. Yeah, we know from the archaeology that these weren't slaves. This was a skilled, paid workforce of about 20,000 people. Craftsmen, builders, all organized into teams, living in their own city right there at the Giza Plateau. Just managing that many people was a challenge on the scale of the pyramid itself. And you know what a city of 20,000 workers needs? Food. A lot of it. Every single day. Hemiunu's people had to bake and hand out something like 100,000 loaves of bread, daily. That's not a building problem. That's a math problem. That's division, multiplication, logistics. That's me, in action. And they couldn't just do this for a week or a month. They had to keep this whole machine running. The quarrying, the building, the baking for 20 years. So you see, the Great Pyramid wasn't just an incredible piece of architecture. It was a masterpiece of project management. A feat of pure calculation, keeping track of everything and everyone. So, after 2 decades of nonstop work and relentless calculation, there it was, finished. Sure, it was a tomb for a king. But for me, it was something else entirely. It was my proof, my thesis, written not on some flimsy papyrus scroll, but in 6.5 million tons of stone. Hemiunu never wrote any textbooks about me. He didn't need to. For almost 4,000 years, that pyramid was the tallest thing ever built by human hands. The way it's lasted, how precise it is, how it's perfectly lined up with the stars, the pyramid is the textbook. It's the ultimate proof that my practical, get-it-done approach worked. For a long, long time, my story in Egypt was all about practical power. It was about solving real problems for real people. But then, centuries later, some new people showed up, visitors from a place called Greece. And they stood there, looking at my masterpiece in Giza, and they started asking a totally different kind of question. You see, the Egyptians, they always asked, how? How do we make this ground level? How do we get this pyramid to stand up? They needed a tool, and they needed it to work. Simple as that. But the Greeks, they asked why. Why does a 3-4-5 triangle have to make a right angle? They weren't just looking for a tool. They were hunting for something deeper, for eternal logical truths. And this new quest, it was really championed by guys like Pythagoras. The story goes he actually studied in Egypt, learned all my practical tricks, but when he went back to Greece, he had this wild new idea. He started to believe that I wasn't just a tool for building stuff. He and his followers thought that mathematics, was, well, the secret language of the entire universe. But here's the thing. This search for a perfect, orderly universe, all built on nice, clean, whole numbers, it was about to run into a huge problem. Because hidden inside that simple practical geometry they got from Egypt was a disturbing secret. A number that would break all their rules. A number that would threaten to tear their entire worldview apart.